Algebra 2, Chapter 6 test preview. Later this week, we're going to be having a test over Chapter 6 plus synthetic division, which we covered at the very first of this semester. Problem 1. Graph the parent function, the parent cubic function. This is f of x equals x cubed, and use the graph to answer each question. So basically, if this is excerpted from an earlier exercise we did, and I'm not going to do the whole thing here. Now, to graph the thing, it's going to look like this. Now, you're going to be able to have your calculator in hand for this test. So anyway, the graph of the function looks something like this. Okay, oops. Kind of get a little glitchy there. All right, very good. That's as close as I can get. Okay, and it says, state the function's domain and range. Well, the domain is going to be all real numbers, greater than negative infinity, less than infinity. Our range is similar, going to be greater than negative infinity, less than infinity. Identify the function's end behavior, and it's going to be as x approaches infinity, f of x, or the output value, also approaches infinity. And also for end behavior, we have to consider not only about x approaching infinity, but x approaching negative infinity. And that's going to be as x approaches negative infinity. That's negative infinity there. F of x approaches negative infinity. Identify the graphs x and y intercept. Well, I'm not going to go over those. Identify the intervals where the function has positive values and where it has negative values. So we'll say f of x is greater than 0 where, or on the interval from greater than 0 to infinity, and f of x is less than 0 on greater than negative infinity to less than 0. Identify the intervals where the function is increasing and where it is decreasing. Well, the function is increasing everywhere. Next, for f and g, tell whether the function is even, odd, or neither. Explain. Well, the function is odd, and one thing that tells you that it is odd is the type of symmetry it has. And I'm going to demonstrate it here by rotating. So when a function has, I rotated it 180 degrees, and it rotated upon itself. So that is a graphical definition of a function having odd symmetry, and therefore odd. And similarly, describe the graph symmetry. Symmetric about the origin, or I like to say 180 degree rotational symmetry about the origin. So that would cover as much as I want to problem number 1. 2. The graph of fx equals x cubed with 3 reference points is shown. What are the coordinates of a transformation of each point according to the transform function g of x equals negative quantity x minus 3 cubed minus 5. We can do this problem a number of ways, one of which is to take the values in here to see what happens if we put an input value of 1, what is going to happen. So if we put g of 1 for this point at the right, is going to equal negative. We're going to substitute 1 and put minus 3 here, cubed, minus 5. And what that's going to do is g of 1 is equal to, well, we take this negative, and 1 minus 3 is negative 2. So negative 2 cubed minus 5. Well, negative 2 cubed is negative 8, but this minus outside makes it positive. So we get 8 minus 5, or 3. So what we get for this is the point 1. Well, I got to really do more than that in this instance. I'll tell you why. We got to translate this first. Okay, remember this g of x, or f of x, equals a times x minus h cubed plus k. Remember that? Well, the h is the one that shifts left and right, and the k goes up and down. So what we have is our center point, or our inflection point, is going to be the point h comma k, which in this case, for this particular instance, is going to be 3 comma negative 5. So what we do is we take this point here and shift to the right 3, and then we go down 5. So that's what we have here. We do that, but what does this negative sign do? Well, negative sign is going to move the thing way up here. So we reflected about the, but then we bring this down here. So so this thing is not going to reflect, so it's going to move up here, down. So in this instance, the best thing to do might be to go ahead and go to the calculator, say, okay, we'll have negative quantity x minus 3 cubed, and we'll put minus 5 and see what happens here. So what we do is we turn the thing upside down. Now see, our vertex is right here. So that was right here. Turn upside down. So 3 minus 5, that's going to be right here. 3 negative 5. We can go take a better look in our calculator if we go to the format and we go to grid, put medium gray, that's on, and now graph, and I don't see anything different. Okay, we've grid line. That's what I need to do. I need to go grid line. There we go. Now we should see it. Yeah, so 3, negative 5, and the thing turned upside down. So what that did is as far as each point, well, the 0, comma 0 is going to go over to 3, comma negative 5. This point, and I'm going to draw what it looks like here. The thing is going to look like this. So what that's going to do, it's going to take this point here and we'll transform it 3 to the right, but it'll be right here because of the reflection up. So the point negative 1, comma negative 1 transforms to 2, negative 4. And then the 1, comma 1 transforms to the coordinate pair 4, comma negative 6. Okay, so this will be our answer. And the best thing I can suggest is take a look at the graph in the calculator and just see what happens to the points, and that'll be it. Next, 3. Describe how the graph of fg of x is related to the graph of fx equals x cubed. Well, this will be the value of h. And we can graph this in the calculator, but we will say f of x is translated three units to the right. Okay, next. 4. Describe how the graph of g of x is related to the graph of fx equals x cubed. Well, we have two things going on here with this negative 2/3. We have an absolute value of less than 1, so f of x is vertically compressed by a factor of 2/3. And f of x is also, and that's what the negative sign does, is also reflected about the x-axis. Next, 5. Describe how the graph g of x is related to the graph of fx equals x cubed. What we have is this cube distributes inside parentheses to the 5 and the x. So what we have is 5 cubed, and 5 times 5 times 5, that's 125. X cubed minus 2. So we will say f of x is vertically stretched by a factor of 125, and translated down 2 units. Okay, next. A cube function with the general equation of h of x equals a times quantity x minus h cubed plus k is graphed below. Write a specific equation for g of x by identifying the values of the parameters from the reference points shown. So basically, we can take our vertex here, and we have a vertex at negative 3 comma 2. So we can write this as h of x equals a times quantity x, and we have minus negative 3, so we put x plus 3 cubed plus 2. And what we're going to do is use a second point, and we can use either of these second points that will help us get the job done. I'm going to use this first one here, negative 4 comma 5. So I'll say using negative 4 comma 5, we're going to substitute in and find out. So we have 5 equals a, which was what we're trying to find out. And then we have x is negative 4 plus 3 cubed plus 2. And we get negative 1 cubed, so 5 is equal to a, and negative 1 cubed is negative 1 plus 2. So we subtract 2, we get negative a equals 3, so a is equal to negative 3. And so our specific function is going to be h of x. We'll say, I'll just write down here, h of x equals negative 3 times x plus 3, quantity x plus 3 cubed plus 2. And to test out our function, we can go to our graphing calculator and put in here negative 3. I'll just clear this out. Negative 3 times quantity x plus 3 cubed plus 2. And if we see all the points represented that we had, we know that we are right. We graph, and so we have an inflection point at negative 3 comma 2, and then we should have a point at negative 4 comma 5. It looks like we have that, and we should also have one at negative 2 comma negative 1. Let's check. Let's go to the table view and check and see if we have that. Second graph at we have negative 4, 5. We have negative 3, 2. And we have negative 2 comma negative 1. So that all checks out. So it's all there. We're sure of that. Let's go on. Problem 7. For the function fx equals negative 8, negative x to the 8th power, answer the following. Is the function odd or even? Well, we have a negative, even. So even will be our answer here for this one. And we can tell when we graph, we go here, we say negative x to the 8th power. We graph the function. That's what it looks like, sort of upward down, upside down, kind of flat on the top of u. What is the domain of the function? Well, the domain of the function is the same as it is for any polynomial function, which is all real numbers. Greater than infinity, less than infinity. What is the range of the function? Well, the function goes from negative infinity up to and including 0. So our range is going to be a greater than negative infinity up to 0 and including. So we box that off. What's the end behavior of the function? As x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, going to the left, f of x also approaches negative infinity. Negative infinity both ways. Eight, use a graph calculator to graph the function f of x equals negative x times quantity x minus 2 times quantity x plus 1, then use the graph to determine the number of turning points and the number and type, global and local, or just local, of any maximum or minimum values. So when we graph this in a calculator, I'll just do this right now. We have negative x times quantity x minus 2 and x plus 1. So here we have it. So we have two turning points, looks like. And this minimum and maximum, respectively, are both relative or local because they are not the absolute or global. So we will say two turning points. And both of our extrema are just local. So we have one local maximum and one local minimum. And is that going to be it? Yeah, with the number of turning points. That's about it for number 8. 9, use a graph calculator to graph the function fx equals x cubed times quantity x minus 2. And this one I'm going to do without a calculator, just to show I can do it. If I go like this, we're going to have x equals 0 is one of our zeros, and x equals, I want to say 2, but it's going to be x equals 2. So this first one has if we look at this, we're going to have x cubed times x, which is going to be x to the 4th, and that's going to be a positive, even positive behavior. So x equals 0 and x equals 2. And so we have even positive. We're going to start high and we're going to end high. And so we go to, so we start here. We have x cubed, which is odd number multiplicity, which we're going to cross, and cross in this manner. And then we're going to come here to this other one at x equals 2 and cross. So that's going to be x equals 2. That's what the graph's going to look like. We have just one turning point. And we only have one minimum, and that is going to be a global and local minimum. One global, which also means local, minimum. So that's going to be number 9. And again, yeah, I'll just do that in the calculator too. We go x cubed times quantity x minus 2. And graph this. See, just as we sketched it here. Starts high, ends high, crosses, 1, absolute minimum. Okay, next. 10. Sketch the graph of fx equals x cubed times 20x minus 2 times 20x plus 1. Now, the language in this problem doesn't say anything about using or not using a graphing calculator. I'm going to graph this without a graphing calculator, but keep in mind that if you were handed a graphing calculator for the test, you can use it to either use a graphing calculator from the get-go or to check. So we have x is equal to 0 as 1, 0. We're going to have x is equal to 2, and we have x is equal to negative 1. If we mark each 0, 0, 2, and negative 1, and we should realize we have x squared times x times x. We're going to have x to the 4th power. So like the last problem, we're going to start high and end high. So we're going to go to our first 0 at negative 1, and we have a multiplicity of that 0 of 1, and the multiplicity of the 0 at 2 is also multiplicity equals 1. At x equals 0, we have a multiplicity of 2. So starting high, we're going to start high, and what happens at negative 2? We have a multiplicity of 1. So we are going to actually cross, and then we're going to go down here, come back up to this next one at 0. We have a multiplicity at 0 of 2. So we're going to bounce and come down here like this. And then we're going to go back up like this. And to verify, like I said earlier, we can use a calculator. And it's going to look something like this. I think this one here is going to go down very much. The one on the left, the one on the right is probably going to go down farther, but let's just see what it looks like. We go down to graph. We have x squared times quantity x plus 1 times quantity x minus 2. And we see what that looks like. Yeah, pretty similar to the way I drew it here. Okay, yeah. So that'll be it. Now 11, an x by x square is cut from each corner of a rectangular sheet of cardboard that's 10 inches wide and 14 inches long. The sides are then folded up to form a box. And so this is a very classic type of polynomial real-world problem. So we have this box here that's 14 inches long and 10 inches wide, like this. And so this is going to be 14 here. And this is going to be 10 here. And out of x, you're going to cut each corner here as a width of x. So each one of these corner dimensions has x. So what that tells us is our dimensions of the box are going to be volume equals length times width times height, which is going to equal, our length is going to be 14 minus 2x. Our width is going to be 10 minus 2x, and our height is going to be x. And so we can put this in a calculator and see what happens. We're going to get we'll be able to see a maximum height and the value of x. So let's go here and we're going to put in our length 14 minus 2x, and then our width is going to be 10 minus 2x, and then our height of the box is going to be x. And we graph the function. This is what we see. I'm going to go ahead and change the dimensions of the window to better view what's going on here. And we go to, let's see, I'll go for width of 5, x max of 5, y minimum, negative 10 is okay. Y maximum, I'm going to go up to 200. I don't know if that's going to be enough. Anyway, I'm going to go to y, scale, graph. So we're going to see a maximum height, right? Maximum volume is going to be right here where x looks like it's about 2. So let's go to second trace, and we go to maximum 4, and it says left bound, so we just arrow to the left of that maximum, press enter. Then it says right bound below, we arrow to the right, we press enter, and enter our last time. So we get x equals 1.918. I'll call it 1.92. So x 1.92, and to the nearest tenth of an inch. So we say x is approximately equal to 1.9 inches. And what is the volume of the box going to be at x equals approximately 1.9 inches? Well, it's going to be 120 cubic inches. Okay, next, problem 12. Write a quartic function in intercept form or factored form for a given graph. I think the test will say intercept form, but factored form is a way that I've said it also. So we're going to have x is equal to negative 2, x is equal to 1 down here, and x is equal to 2. And so the zeros associated with this, we have x is equal to negative 2. To find the factor associated, we have to set one side equal to 0. So we add 2. So we have x plus 2 is equal to 0. And that is going to be, we have a bounce there, so that's going to be quantity x plus 2 squared. And next we have x is equal to 1, and subtracting 1, we have x minus 1 equals 0. So that's going to be another factor. And finally, we're going to have x is equal to 2. And if we subtract 2 from both sides of this equation, we get x minus 2 is equal to 0. So that's a third factor. So our function is going to be f of x is equal to quantity x plus 2 squared times quantity x minus 1 times quantity x minus 2. And we should see the same thing here. So let's do that. So we have quantity x plus 2 squared times quantity x minus 1 times quantity x minus 2. And we'll see if we get the same thing that we had earlier. I'll press zoom 6 to get a standard window. And does that get the same thing that we had here? Let's check. Well, it looks quite similar. Yeah. Minimum of -3, -2, 1, 2. Maximum of about 8 or 9. What does that look like here? Yeah. 2, 3, 4, 5, 6. Yeah, so that's right. This is going to be a good answer for us. Okay, and then we have these last three in this test preview are regarding to polynomial division. So we're asked for the polynomial division x minus 2 as the divisor and x cubed minus 3x squared plus 5 would be a proper synthetic division setup. Well, for that, we will take the value of the 0, and to do that, if we see x minus 2 is equal to 0, then we x is going to be equal to 2. So 2 is going to go out here, and then we have 1x cubed minus 3x squared. And now this is critical. We don't have any x's represented, so we're going to have to put 0 here, and then 5. So this is our proper synthetic division setup, and this is going to be our correct answer. And going ahead, we could perform that division quite easily too, and that we could find that if needed, but that's as far as we need to go. Okay, if 2x cubed plus 3x squared minus 6x plus 8 is a dividend, and x minus 3 is a divisor, what is the remainder of the quotient? So we can find that out in a couple different ways, but the one we've been doing is using the synthetic division. So we put 3 out here, and we're going to put 2, 3, -6, and 8. We're going to bring down the 2, so we get 2x squared, so that's 2. 3 times 2 is 6. 6 plus 3 is 9. 3 times 9 is 27. -6 plus 27 is 21. And 3 times 21 is 63. And our remainder is going to be 8 plus 63, or 71. So our remainder is equal to 71. And if we wrote this out as in a presentation form, we would write this out as 2x squared plus 9x plus 21 plus 71 over our divisor, which is x minus 3. But our answer here is 71. Okay, the last one in this set is we have a polynomial divided by a polynomial. So I'm going to use our synthetic division for this. We're going to put -2 on the outside here. And we have 3x to the 4th power, 2x cubed. Oh, we don't have, that should be x cubed. I'm going to have to make sure everybody understands that. We're going to have -5x squared, and we're going to have 6x and minus 12. So I'll bring down this 3. So we have 3 down here. -3 times 3 is -6. 2 plus -6 is -4. -2 times -4 is 8. -5 plus 8 is 3. -3 times 2 is -6. And 0. -2 times 0 is 0. So -12. So our answer, or quotient, is 3x cubed minus 4x squared plus 3x, and then we have plus 0 minus 12 over x plus 2. And so this is going to be our answer to this last problem here. Hope this has been helpful to you. Good luck, and thanks for viewing.